Now let's see the case of callback functions. So we have already seen that a function in JavaScript can just be handled like an object. That is, it can be passed as value to a parameter or a variable, and it can be referenced to that variable. Okay, so that particular property is used in case of callback functions. So a function which can be passed as argument to another function, that is known as a callback function. So actually it can be used to alter the behavior of an already existing function. So let's see an example. So over here you can see that we have two function definitions. One is a greeting function, another is process user input. And you can also observe here that process user input is the parent function that is invoked. Okay, so what is this greeting function? This greeting function will accept a string, right? And it will print an alert message with a hello message. Now process user input actually takes as argument a particular argument, right? And that argument is used to invoke a function call. So it means that this argument has to be a function. So here we are passing the name of the callback function just like a reference. Okay, so what is process user input doing? Actually it is prompting the user for the name, and then it is passing that name to the callback function, and the callback function is in turn greeting the user. Okay, so let's see how this behavior works. So this is this callback. This is a HTML script that actually invokes the callback script that we saw earlier. So it is asking for a name, so I am entering a sample name, and then when I click OK, actually what happens? The process user input is passing the string to that particular callback function. All right. So in this case, the callback function was greeting. So greeting is printing the hello message. So let's actually see how callback function can be used to alter the behavior of sort method. So we have already seen sort method as an instance method of array, right? It will sort a given array, converting all its elements to string and in alphabetical order. So it is by default an ascending order sort. So suppose that we need to change the behavior of the sort function. Okay, so sort function by default accepts a single argument, that is a comparison operator argument. It has to be a callback function or a function that can return a possible set of three outputs. Okay, so the possible set of three outputs that are expected out of the comparison or comparator function that we pass to sort as an optional argument are these, that is 0 or a positive number or a negative number. Okay, so if as a result of this sort, if we wish to, okay, suppose that we are having an array, right? And suppose A and B are the two adjacent elements of the array in order. Okay, so A proceeds before B in the given array, right? And suppose that we wish to change the orders of A and B such that B will take A's position and A will take B's position. In that case, our callback function that we pass to sort should return a positive result. Then and suppose that if we wish to retain the positions of A and B in order, right, that is their actual positions, then what we can do, we can either have these two results, that is either we can have a negative result returned or a zero result returned. Zero result actually explicitly mean that A and B are equal. Okay, so if A and B are different, then we expect actually a negative number to hold them in place. Okay, so here what we are seeing is a callback function named numOrder, which acts as a comparator operator and which changes the default behavior of sort. Okay, so here an example is given. So what happens here? Here the first element and second element are taken as arguments from the array, right? So if you see here, num list happens to be an array. Okay, num list happens to be an array and the sort function is called on the array, but with an argument of this function as callback. So this function actually acts as a comparator operator for the function sort. So let's analyze the behavior of sort now. So A and B in order are passed. Then what is done? B is actually that we are subtracting A from B. So if it returns positive, what does that mean? It means that B happens to be greater than A, right? And so let's see the case when they have to remain in position. So when B is less than A, right, they will remain in position. So it means that if the first element is greater than the second element, it means that they will be in position. So it means that it is a descending order sort that we are trying to achieve. Okay, so if we are trying to achieve a descending order behavior for the sort, maybe with numbers. Okay, suppose that we are trying to handle them as numbers instead of converting them to strings. All right, then what we can do, we can have such a function which will change the default behavior of sort to descending order behavior. Okay, so an example is given over here. So here a median computation is done. Okay, so let's see which are the main functions and which are the sub functions. So if you see here, this is the area where the actual parameters are formulated or passed. Okay, so we have two lists, my list 1 and my list 2, and my list 1 is this, my list 2 is this, and then we have a median function over here, a median function call over here. So this median function is the main function. All right. Okay, so let's see or analyze the behavior of median function. Okay, so the median function definition is given just above. So this median function takes a particular argument, okay, and a sort is called on that. So we assume that it's an array, right? So let's see how the sort works. So sort's behavior is altered through a comparator function, and note the structure of this function. This function is an anonymous function because it doesn't have a name. Okay, earlier we saw actually a callback function, a named callback function being passed. So this is an anonymous callback function being passed. So let's analyze its behavior. Suppose A and B are adjacent elements in this array, right? Then how will they remain in position, or under what condition will they remain in position if A is less than B? Okay, if A is less than B, then negative value will be returned, so they will be in position. Okay, so when will A and B change their position? A and B will change their position if A is greater than B. Okay, so for all A greater than B, what happens? Okay, for all A greater than B, there will be a swap, right? So this is actually an ascending order sort. So this actually will sort the elements in ascending order, and then median computation will take place. Okay, so the first thing for median computation is we need to sort the array in either ascending or descending order. Then length of the array is determined, and then we have two cases when the length is odd or length is even. So if length is odd, it is pretty easy. We can zero in to the middle element, right? So that is done over here. If the length is even, we have to take the average of the numbers at the center, right? So that will give the median. So this is how this function works. So the main thing here is the comparator operator that is passed as callback, anonymous comparator operator.